Hello everyone. So today we're going to go ahead and talk about a little bit of a review for our mid-unit quiz coming up, which if you're watching today, is tomorrow, but hopefully you were able to try the review for yourself and now you are seeing if your answers are correct. So hopefully we can go ahead and do that. I will not be giving all the answers, but I will give in a good amount. Okay, so let's go ahead and look at this graph, this pretty little graph, right? Made by yours truly. But let's go ahead and see some characteristics about this, and hopefully we can answer most of these questions. So this right here, I like to see it from left to right. So I'm seeing that this arrow is it's coming from all the way to the left. So it's coming from negative infinity. And if I look at this, it looks like all of this area is decreasing, right? All of this is decreasing, and it's decreasing until this point, until x equals 2. And then we have a change in slope. So now the slope is increasing. So let me go ahead and put that as a different color. So let's go with green. So right here, now it starts increasing, right? All of this, right? The height, the range is increasing. Okay, and then we get to another point, and we can probably see that at x equals 1, right? At x equals 1, we have this this max, and then it starts decreasing as well. So then it decreases, and then for funsies, I went ahead and put a hole in there just to see where you guys were at, and we get to see that at x equals 2, right? At x equals 2, I have a little min, and then I start increasing as well. I'm going to go ahead and label that hole in red just so we can make things clear that this right here is removable discontinuity, also known as a hole. And then we have that it continues to increase as well. So all of this increases to infinity, right? Infinity and beyond. So the next thing this function is asking me is the following. So I'm going to go ahead and write in my answers in red. So let's go ahead and do that. And we can go ahead and see that this right here is going to be my domain. So how far left does it go? How far right? So I'm going to go ahead and see that these arrows are going to tell me a lot of information, right? So how far left can I go? Well, I'm going as far left as this can go. So it's going to be negative infinity. And I'm going, right? Then I'm going all the way right that I can go. So keep in mind the range is going to go up and down or whatever it's going to do. So it goes down here, it goes up. But in reality, the domain is still continuing. My x values are still being accounted for. So I'm still being accounted for my x's. But this point right here, when x equals 3, my height at 3, there's a hole. There's a removable discontinuity. So therefore, I need to go ahead and say that I can't continue at 3. So I'm going to put a union, then jump over that hole, right, and continue at 3. And I can see that all my domain is still accounted for, right? My function is going to up to infinity. So I have like that. So I wanted to say that it was from negative infinity to positive infinity, but we need to notice that there is a hole at what appears to be x equals 3, right? At x equals 3, my function has a hole. Alrighty, let's go ahead and try the next one, my range. So how low to how high can this function go? So can you go down low? Well, actually, the lowest I can go is right here, my x equals negative 3. But I can physically put a point right here. Hopefully you guys can see that. So the lowest I can go is negative 3. And I'm going to go ahead and see that it goes all the way up. Now this part right here at y equals 3 looks a lot confusing, but in reality it's still accounted for. I can still have a point at y equals 3, right? And it continues all the way up to positive infinity, right? My y's, right? My y's go all the way up because this little endpoint approaches infinity. Already increasing. So increasing, I can go ahead and see that that's pretty much where I colored green. So it's going to be from this point right here, right? This corresponding horizontal x equals negative 2 all the way to this right here, right? My x equals 1. So I'm going to go ahead and put that. It's increasing from -2 all the way to +1. Then it stops, right? Because over here we have a decreasing. So it stops. So I'm going to put union. Then it continues from x equals 2. Keep in mind there's a hole, so it's going to mess with us a little bit at x equals 3. So from 2 to 3, 2 to 3, it continues to increase. Then I'm going to go ahead and jump over that hole, if you will. And it's going to go ahead and go from 3 all the way to all the way that it's increasing. And we can see increases until infinity, right? Because that arrow is going both up and to the right. Okay. Similarly, decreasing, and I'm seeing a lot more students that are struggling with this, specifically this part right here, this endpoint that is pointing towards the left. And they're wondering, well, what does that really mean? Well, keep in mind that is telling you that the function is coming from the farthest left, right? So the farthest left that I am aware of is -infinity, right? Because this is still decreasing. So it's decreasing all the way from the left most part of the graph, right? So it's decreasing all the way to where it is not, right? Which in this case is -2. Then it continues to decrease. So I'm going to put a union, right? Because we have another decreasing part. And it says it is from 1 to 2. Awesome. Alrighty, let's go ahead and try my maximums and minimums. I'm going to go ahead and use purple. And hopefully you can see that this right here, this point right here is a minimum, right? This right here is a max. And this right here is a minimum. Okay, so we learned that there is a difference in these minimums and maximums. We learned that they were called extrema, and that there's absolute extrema and there is local, right? So anything that is the highest you can go and the lowest you can go, right? If this point right here, let's talk about this specific point. If this is the lowest I can go and there's nothing lower, this is absolute. So this, in this case, it's an absolute minimum because there is no graph that you can see is lower than this point. Let's look at this max right here. Is there a function higher than this? Well, specifically, you can probably see that these points are all higher than this max. So this is local, a local max. Same thing goes, this minimum right here, right? This minimum right here. It is a minimum, but notice how this minimum over here that we said was absolute is way lower. So this one is just going to be a local min. Okay. So we're going to go ahead and try this real quick, and we're going to go ahead and label these points. Local minimums, we have it at x equals 2, or if you want to be more specific, the actual location is 2 to the right and 2 in height, 2 in the y-axis, +2. Is there a local maximum? Well, we just said there was. It's this one right here, and that is when x is equal to 1. We can be more accurate and say the location is when it's 1 and 3 in height, right? 3 up. Is there an absolute minimum? Well, yes, there is. There is actually one where it's x equals -2. We just found it. And then my height, I'm sorry, and then my actual location is -2. So 2 to the left and 3 down, so -3. Is there any absolute maximums? Well, hopefully you saw that this goes all the way to positive infinity. So there, the highest we can go is infinity, but we cannot physically put a point on that, so there's none. And that's okay, guys. Symmetry. Keep in mind we have even, we have odd, and we have none or neither, right? In this case, is this symmetrical across the y-axis? If I split this right here, right? If I split this on the y-axis, is this symmetrical? My left is the same as my right? Well, no, right? We can probably see that if I fold this like a hot dog style, it does not match, right? My left does not match my right. If I check my across the origin, the quadrants, are they symmetrical amongst diagonal quadrants? Well, no, they are not, right? Quadrant one is not the same as my quadrant 3, right? And so forth, the second and the fourth. Boundedness. What? Really like this. Let me use my laser. Boundedness means that this function is pretty much restricted, right? Bounded, restricted to an extrema. So we're going to look at all our points. This absolute max, this local max and this local min. And we're gonna see if we could draw a line right here under this minimum, can my function pass it? Well, if it cannot, right, in this case, it can't go lower than this point, it is actually bounded. So in this case, it is bounded below, right? It is pretty much bounded at this line. Similarly, if we were to look at this right here, I was trying to bound this to the top, we can see that this little arrow right here is probably going to pass that line that I draw. Okay, something you also need to know is composition of functions, and this is something that we talked about today more in depth, but I have an example right here and hopefully it wasn't that bad. So pretty much composition of functions is you put one function into the other and you get to see some pretty neat stuff. So in this case for A, it's saying, go ahead and find this fog. Keep in mind, this is not the only way they write it. They also write F bracket G of X. So keep in mind that that's the same thing. But what this really means is I'm gonna go ahead and put my G function into my F. So let's go ahead and write this out. My F function is X squared. And I'm gonna go ahead and put my G function inside there. So it's gonna be now parentheses squared, and inside those parentheses, I'm gonna go ahead and get my F function, which in this case is my negative 5x. I do some simplifications, I get negative 5x times negative 5x gives me a nice 25x squared. Alrighty, let's go ahead and try the next one. Find gof of x. Keep in mind that's the same thing as saying g parentheses f of x. Pretty much showing you that you have one function inside the other. Okay, let's simplify a little. I like to write my g function, which is negative 5x. So keep in mind, I'm gonna write it again, but with big parentheses so I can put my function that they just told me, which is f. In this case, f is x squared. So I simplify this as negative 5x squared as my solution. Ooh, these are nice. I prefer these the most. So fog of a value. You could either do the same thing and then substitute x equals 1, right? Or you can do it from the start, which I pretty much encourage you to try that. But either one will give the correct answer. So pretty much you put the 1 inside my g. So my g is negative 5x. Sorry, guys. It looks like my handwriting gets pretty bad when I get carried away. Okay, so and I substitute my 1 for my x, right? X is equal to 1. So now I have negative 5 is my g of 1. So hopefully you remember that you get this new value and you substitute it into my f, right? Into the other function. So negative 5 into my f function, which is x squared. So it's now going to be negative 5 squared, which is 25. Awesome, awesome. Okay, let's go ahead and try one last one, which is graphing. Okay, oops, just kidding. Well, now we know there's second to last. Okay, so what I want you to do is look at these lines right here. These are restricted to certain points, and it's showing me that for negative 4, so negative 4 is right here, negative 4. Right, this is x equals negative 4. X equals negative 4. And we got x is equal to positive 1 and x is equal to x is equal to 1 and x is equal to 3, which is 1, 2, 3 right here. Almost missed it. Okay. Alrighty. So pretty much what we're going to go ahead and see is that there is 3 different functions for this piecewise function. What I like to tell students is that you can go ahead and make a little number line and split this up on your own, negative 4, 1, and 3. And you can go ahead and see that you can split this up, and this tells you everything you need to know. That this function exists right between negative 4 and 1. So right here is how you should have this function. The next function is 1/2 x, right? And that exists between 1 and 3. So this is 1/2 x. And we can see that -3 exists every time x is greater than 3. So this is -3. Okay. If you don't like that, or if, depending how you learned it, you could be talking about lefts and rights, but that does get a little messy, right? So let's go ahead and graph these. I like to go ahead and make little tables. So I'm going to make a table. So x minus 1. And I'm going to make a little xy table just to help me go ahead and put some points on here. And I'm going to make another table for my other function, which says it's 1/2 x. And I make my x, y table. And I'm not going to make one for -3 because hopefully you can see that no matter what you pick for x is going to be a -3. So we can actually graph that when any number that is x is bigger than 3. So any on this area right here, right? Anything to the right. Let me go ahead and erase that. We can go ahead and see that it is going to be -3. So I'm going to go ahead and draw that. Go ahead and put it in red. It's going to be 3 below the x-axis, so something like that, no matter what you pick. So it could be 4, it could be 10, it could be 10,500, it could be 1,000,003, and it'll be like that. Keep in mind this has a solid dot because of the brackets. I'm going to put my solid dot and make it noticeable because my function does not exist to the left or when x is less than 3. Okay, so that's why I'm not going to do that table, but we can do the rest. Okay, so for x is -1, I'm picking all the numbers, let's say from -4 all the way to 1. So -4, -3, -2, -1, 0, and 1. Quite a bit. Okay. And for my other function, I'm going to pick the numbers between 1 and 3. So 1, 2, 3. All you have to do is substitute into your function and pretty much simplify, right? You get these numbers, you substitute them into your function and simplify. So -4 minus 1, that gives me a -5. -3, I substitute into my x, that gives me a -4. Pretty much everything's going to be subtracted 1, so -3, -2, -1, and 0. Okay. The same thing goes here. You go ahead and substitute into here. So 1 times 1/2, that's 1/2, right? Or if you like decimals, you can put a 0.5, it's up to you. 2 times 1/2, right? That is 1. And 3 times 1/2, that is 3/2. Or if you like decimals, this is 1.5. All you have to do now is plot these points. So let's go ahead and plot these points. So I'm going to go ahead and say that this one is a solid dark blue. So that's going to be -4 is my first point, -4 and -5. So 4 to the left, 5 down. So like that. All right. 1, 2, 3, 4, 5. Okay. And then we keep doing the same thing, -3 and -4. And since it looks linear, we should be able to see that this is going to be negative. Did I miss a point? I believe I missed a point, ladies and gentlemen. Yep. I clearly saw that this was right here. This was -4. Awesome. No worries. So -4 is -5. So same thing. 1, 2, 3, 4, and 1, 2, 3, 4, 5. So here should be my point. And since it has a little solid bar, it has a solid dot. Okay. And I'm talking about the inequality symbol. Then the same thing, we can go ahead and plot these points. Then 2 to the left, 3 down. And then we just do the same exact thing, right? Then 0, -1. Okay. And then here, be very careful because the 1 is open. So I'm going to leave that open dot. And I'm just going to connect the points. Alrighty, almost done. And we have these right here. So when my 1 is here, it's going to be 1/2. And I see right here that it's going to be a solid. So when x is 1, there's going to be 1/2. So 0.5, which is a solid dot right here because the inequality bracket right here, the little bar tells me that it is solid. And then 2 is 1, and then 3 is 1.5, which is going to be open because the 3 only has a little Pac-Man symbol. Okay, and I just connect those dots, and that's how you graph a piecewise function. Alrighty. Last but not least, how about evaluating? So similarly, what I want you to know is you can make a little chart, and this is you're going to be restriction. So it says -2, and you can decide on what part of the function this belongs to. So this is when x is less than. So everything that is less than is smaller numbers than -2. So what's smaller than -2? Well, that's numbers less than, so -3, -4, -10,000, -1,000,000, stuff like that. So everything to this left-hand side is going to be affected by this function. So hopefully you can see that everything that is greater than or equal to is going to be by this function, the absolute value of x plus 4. If you prefer to look at the domains, that's perfectly fine too. This would be from -infinity to -2 parentheses, and this one would be everything to the right, including -2, so this would look like that. It's completely up to you. They both work out, and all you have to do is substitute depending where they're at. So -3, right, my x is this value right here. When x is -3 is on this side. So I'm going to go ahead and use 1/2 x minus 1, which is this one right here. So it's going to be 1/2 times my x, which we just said is -3, minus 1. So it should be -3/2 minus 1. Here I try to see if you guys were able to do some manipulation for the fractions, and 1 is the same thing as 2/2. So you should have -5/2. Okay. The next one says f of -2. -2 is only included on my bottom because of this little bar right here. So under the absolute value of negative, parentheses, x plus 4 in absolute values. So it's going to be -2 plus 4 parentheses. So it's going to be negative makes me positive plus 4 equals absolute value of 6, which is just makes that +6 a positive, which stays positive. Stay positive, my friends. Okay. And last but not least, what happens when it is 2? Well, 2 is right here, so it's still the same thing. So it's going to be using the same equation. So it's going to be x is equal to 2. So now it's going to be the same exact thing. Or is it? Oh, no, it's not. It's going to be 1. I'm sorry, it's going to be absolute value of -2 plus 4, which gives me a 2. So absolute value 2 is 2. Alrighty, so I almost made a big mistake there, but this is all that we have, and you want to be absolutely correct. You can do f of 2 is 2, f of -2 is 6, specifically when you're doing your AP exams. Okay, hopefully it didn't take that long, guys, and hopefully this helped you refresh for tomorrow's quiz, right? Okay, so let me know how it goes, and I'll go ahead and stop.